All right, guys, so go ahead and open your packet to standard 16 here. So we are graphing just sine and cosine to begin with. To do that, we need to evaluate some of these values. So we're going to start with just the sine values. All right, so the first one I have up there is negative 2 pi. Where is negative 2 pi? Some of you didn't like the negative values. What does it mean to have a negative angle? Yeah, we're just going the other way. So if we go negative 2 pi around, where do you end up? Yeah, it's right at the same spot, right? So we can think of a little, you don't have to write this, but just to remind you. So we would be over here, right? What's my ordered pair over here? 1, 0. Okay, so what is the sign over there? Is it 1 or is it 0? 0, okay. So the sign of negative 2 pi is 0. What about the sign of negative pi over 2? I'm going across, we don't really have to, but. Sign of negative pi over 2. What did you say, Lexi? Perfect, negative 1. What about the sign of pi? Is that where pi is? 0, good. Guys, do you notice that I'm only picking values that are from these 4 points? Okay, that's all I'm asking you for right now. All right, so let's keep going. What about sign of negative 3 pi over 2? Is it 1 or negative 1? Let's think about it, okay? Negative 3 pi over 2, that would be all the way to here. Okay, so it is positive 1. What about the sign of 0? 0. What about the sign of 3 pi over 2? Negative 1, okay. What about the sign of negative pi? 0, good. Sign of pi over 2? 1. And the sign of 2 pi? 0, okay. We feel pretty okay evaluating those. I know you don't like the negative angles, but we're doing okay. Hanging in there. All right, so now we're going to actually plot these on a graph. So if you look at the graph I have down here, the input or the x value on my x-axis, that's the angle, the pi over 2, the pi, 3 pi over 2. And the output, meaning what I get when I evaluate it, that's my y value as far as plotting ordered pairs. So if you look at the first one up there, sign of negative 2 pi. So when I go to negative 2 pi on the x-axis, what's the output? 0. So that's my first dot, is negative 2 pi 0. You see it? I'm going to actually go in the columns this time because they'll be in order. So when I'm at negative 3 pi over 2 on the x-axis, what's my output? 1. So there's my next dot. When I'm at negative pi for the input, what is my output? 0. What about negative pi over 2? What do I get? Negative 1. 0 gives me 0. What about pi over 2? 1. Pi. Pi is 0, right? Are you guys noticing the pattern here? Okay, so 3 pi over 2 is negative 1, and 3 pi of 0. We'll give you a second to plot those points, and we'll talk about how we're going to connect them. So what do you think? Do you think that they get connected like that, like in straight lines? No, they do not. When we connect these, you could certainly plot all the values from around your circle. You know how that makes a nice curve of a circle? Your graph is that nice curve. It ends up being a wave that goes back and forth. So you don't really put an arrow at the end, but it does keep going forever. The graph would just continue in this wave pattern. It's called a sinusoidal graph. I know, it's a weird word. So guys, that is your parent graph of sine. You need to know those dots well. For everything that we're going to graph with it, it will start with the placement of those dots in that pattern, okay? And then we'll do transformations of all different kinds to those dots, all right? Okay, so that's sine parent graph. Now we need to do the cosine parent graph. So let's evaluate our cosines, and then I'll let you try to graph it. All right, so cosine of negative 2 pi. Again, we are just using these values. So what do you think cosine of negative 2 pi is going to be? 1. And I'll go up and down this time so we go in order. What about cosine of negative 3 pi over 2? 0. We're just kind of working our way around the circle. What about negative pi? Negative 1. Negative pi over 2. 0. Cosine of 0. Mouth the answer to me. Cosine of pi over 2. 0. Cosine of pi. Cosine of 3 pi over 2. 0. And cosine of 2 pi. Now, try to plot those and sketch the graph with cosine. Let's see how you do. bouncing around looks like we're doing well. That is your parent graph for cosine. It is also a wave. Even though it's cosine, it's still called a sinusoidal wave, okay? Because it's the same up to 1, down to -1. It just continues forever like that. Do you guys notice how the graphs are actually the exact same graph, just shifted? Yeah? Okay. All right, questions on just the parent graphs before we move on to doing a little more with that. Okay, so go ahead and turn the page. Okay, so there's a lot of things we can do to these graphs. If you look up here, we can change the A value, which the absolute value of A is called your amplitude. If you look at the little diagram here, it's kind of small. The amplitude is the distance from your midline to the top or the midline to the bottom. The midline is literally the line in the middle, okay? That's all it is. So amplitude is that distance. The B value, which we are not going to do anything with today, changes the period of the graph. That's how quickly it starts over, that it starts repeating. C is what impacts the phase shift. That's the left or the right. Okay. We may or may not get to that today. And then D is the vertical shift. So that's the up or down. All right. Okay. So I know that we just drew the parent graph. Try to graph the parent graph of sine again for me real quick without looking. See if you can figure it out. Is it the one that starts up at 1 or starts at 0? Starts at 0, okay? Think about where those points are. Look up here and check when you're ready. How'd we do on the parent graph? Those points getting ingrained in your head? And it's up to you how you do it. I tend to start in the middle and do the right side because that's just where my brain goes. And then I just know to follow the pattern on the left side. I do not think about the actual value of each of these because that's not going to help you when we change the B value and the shifting and all of that. So you need to be able to just know position-wise where those points are. Okay? All right. So first one we have here, if we go to the right, is negative sine of x. So I am going to put my parent graph dots on here in red. Okay? If you guys have colored pencils, pens, anything like that, that may be helpful for you today. I'm not going to connect these. I'm just plotting the parent graph dots. I know you might not need them, but I'm going to go ahead and put them on there. So give you a second. When I'm not connecting them, I'm just reminding myself that's where I start my graph. What do you think the negative in front does? Flips it? Yeah, so you're going to be flipping over the x-axis. You can also think about multiplying your y values by -1. So I'm going to go ahead and switch to blue to do the final graph here. So the points that are at 0, are they going to change at all? No. So I know these dots are going to stay. And then if you were at +1, you're going to go to -1. If you were at -1, you're going to go to +1. And then I will sketch in my graph. If you don't use different colors and you try to just do it all with dots, you have a lot of dots on your paper, okay? And sometimes it gets confusing which ones you should connect. So that's what it should look like if you. And you can look at the red one next to it. You guys see how it's just been flipped? Questions on the first one? All right, let's try the second one here that says y equals 2 sine of x. Again, I'm going to start with parent graph dots. Especially right now, guys, it's helpful if you plot them every time so that they become just automatic for you. All right, what does the 2 do? Stretch, yeah. What does it stretch? Like which way? Up, okay, yeah. So up and down, it gets stretched vertically. So vertical stretch. What you're actually doing is multiply y values by 2. It's also a change in your amplitude. So again, those points that are on the x-axis, that are at 0, are they going to change when they get stretched? No. So those are going to be the same. What about the points at +1? Where are they going to end up? +2, yeah. They get taller. What about those that are at -1? -2. All right. There's your graph. Questions on that one? All right, we're going to skip that next one and move on to the next section just because I think you get the multiplying part. Okay, let's look at adding a value at the end. So this is a D value now. Remember, D is your vertical shift. So where do you think this graph is going? To which way? Some of you sitting here like this. Yes, up 2, okay. All right, so again, start with your parent graph dots. Doing them in red. And then where does each graph need to go? Or each dot need to go? Yeah, just take each red dot, count up 2, and put a new dot. Okay, I ask you domain and range this time too. So what's the domain of this one? I know we're only graphing it from negative 2 pi to 2 pi, but is that where, does it stop there? No. So what do we think the domain is? Perfect. Negative infinity to infinity. Okay, and now the range, this is of the transformed graph, so the one that got shifted up to. What do you think the range is? 1 to 3. And everybody okay with brackets, not parentheses? It means we're including the 1 and the 3? Okay. Alright, let's try this cosine one. We have not done many cosine graphs yet. So, parent graph of cosine, I want you to plot those points. So sine is the one that started at 0, 0. Cosine is the one that started up at 1. So I'll do them in red. Cosine kind of looks like a W. And then where am I going on this one? Down. How are you guys doing with the parent graph dots? Is that making sense? I want you to just plot those, and then we'll do all the transformations from there. Okay. What's our domain of this one? What's the domain going to be every single time for sine and cosine? Yes, negative infinity to infinity. Okay. And what's the range this time? Negative 3 to negative 1. Okay. Questions so far? Alright, turn the page. Okay, we're going to do one together, and then I'm going to have you try a few of these. Alright, so first, what do you notice that's different about our graph over here? Nothing's labeled, right? We just have these little tick marks. Okay, you have to label everything. When we get to the period change, you're going to use different labels, but for right now, everything is negative 2 pi, negative 3 pi over 2, negative pi over 2, 2 pi. It's just those quadrantal angles from your unit circle. And then on the y-axis, I see that I'm stretching it by 2 and shifting down 3, so that's going to take up a decent amount of space on the y-axis. So I'm going to go 1, 2, 3, 4, 5. I'm going to go all the way to negative 5. All right, what does the 2 in front do? Stretches, multiplies the y values, right? Okay, think order of operations. Do you multiply or do you subtract first? Multiply. So we definitely want to multiply before we deal with the shift down. So instead of doing all the parent graph dots, then stretching, then shifting, I'm going to go ahead and just go straight to stretching the parent graph dots. Are you okay with that? Just the multiplying by 2 right away? Alright, let's see if we can do it. So, 0, 0. Then the next one, instead of being up at positive 1, where is it going to be? Positive 2, yeah. So So I'm stretching by 2. Still not connecting those yet. After I stretch by 2, where do I have to go? Good. Down 3, right? So 0 would come down to -3. 2 would come down to -1. And guys, I'm going to use a different color since I labeled in blue. Let's go 3. So -2, that's going to come all the way down to -5. On this page, but I'm not going to check. Okay. So guys, let's fill in the little parts that I asked you about here. What is the amplitude of this graph? That's the absolute value of A, remember? So what is the amplitude? It's like your vertical stretch. You can do it, guys. What I thank you. 2. What is the vertical shift? Down 3. What's the domain always? Okay, what is your range? That's the weird one on this. -5 up to -1. You guys see it? Okay. All right. That had a lot in it. Questions? Okay, what I want you to work on this page 2, 3, 4, and 5. Okay, I want you to finish this. Wow, okay, finish this page for me. You've got like 6 minutes right now. You could get a decent start on it. But that's what I want done by Friday when I see you. Okay? So if you don't finish it in here today, I want it done by next class. We haven't done B yet, so you obviously can't do that part. And then the homework that's in there, I'm not going to check any of that next time, okay? We've got a little more to learn before you can do some of that homework. So does that make sense? There's just 4 problems that I'm